Hi everyone, it's Miss Costa here, and in this video we're going to go through all of the topics that you need to know in order to get a grade 6. So this video is focused on number, the next one will be on ratio and proportion and so forth. I've broken them up, but every number topic you need to know in order to get a grade 6 in your GCSE. Okay, so to start off with, we've got a factor tree. So being asked to write 72 as a product of its prime factors. Product means as the result of a multiplication. And prime factors is going to be the prime numbers, which are 2, 3, 5, 7, 11, 13, and going on and so forth. Prime numbers just have two factors, 1 and itself, so you can't find any further factors, so that's why we end there. So what we do is we write 72 and then we find two factors, two numbers that multiply to make 72. Now, ideally, just to make your life easier, you're going to be using one of the prime numbers. So let's start with 2. 2 times by 36 gives me 72. And you know that 2 is a prime number. So as soon as you get to a prime number, you circle it and that tree branch is extinguished. Because if we kept on going, it would be 2 and 1 and then 2 and 1 and then so forth. So if it's a prime number, we stop. Then we try and find the factors of 36. So two numbers that multiply together to make 36. And ideally, one of them is going to be prime. So here we could do 2 again. And we've got 2 times 18. 2 is a prime number, so we circle it. And then we go again. So 18, once again, 2 divides into it. So I could say that would be 2 times by 9. And I circle the 2. And when I get to the end, so 9 can be made by 3 times 3. Both of these are prime numbers, so I circle those as well. So once I've got to the end, I can write 72 as a product, so a multiplication of its prime factors. So 2 times 2 times 2 times 3 times 3. Sometimes I ask you to write your answer in standard in index form. So all you do is you bring together the numbers with the same base. So that would be 2 cubed times by 3 squared. And that's how we'd write any number as a product of its prime factors. Okay, so over here we've got adding and subtracting fractions. On the higher paper, you're generally not going to be given a very simple fraction. It's always going to be a mixed number. So what you want to do in order to add or subtract fractions, you know they need to have the same denominator. And in order to do that, we want to turn them into improper fractions first. So you've got a mixed number, and to turn it into an improper fraction, you say to yourself, how many times, what is 3 times 5? That is 15, and then you add on the numerator, so that would be 16 over 5. So 3 and 1/5 is the same as 5/5 plus 5/5 plus 5/5 plus 1/5, because any whole number is like all parts of that fraction made up together. So it's 3 wholes and 1/5. That's why we do 3 times 5, because it's repeated addition, 3 lots of 5/5 plus 1/5. So it'll give me 16/5 plus 3/4. So I've got them both into improper fractions. But the next thing I want to do is turn them into equivalent fractions with the same denominator. So I want to find the lowest common multiple of 5 and 4. And the lowest common multiple is the first number in both numbers times tables. So I would, that would be 20. So I'd rewrite them both as fractions over 20. And I think to yourself, what do you multiply 5 by to get to 20? You multiply it by 4. So therefore you have to multiply the numerator by 4 as well. So 16 times 4, because this is a non-calculator paper, I'll just show you a quick little trick. It's called doubling and halving. So if you double one part of the calculation and halve the other, you'll get the same end result. So 32 times by 2 is 64. If we couldn't do 16 times 4 in our head. And then what do I do with this side? I'm going to do 4 times by 5 makes 20. Therefore, I have to do 3 times 5, which is 15. Okay, and now they've both got the same denominator, I can add them. So I just add the numerators. So 64 plus 15 is going to give me 79 over 20. And now it says give your answer as a mixed number in its simplest form. So I simply say to myself, okay, how many lots of 20 fit into 79? Well, 2, 4, 60. So that would be 3. And from 60 to 79, there's a remainder of 19. So my final answer would be 3 and 19 over 20. And then I do exactly the same thing for when I'm subtracting. So turn it into an improper fraction. So 2 times 3 is 6 plus 2 is 8. So that would be 8 thirds. Take away 1 times 4 is 4 plus 1 is 5. 5 quarters. I have to turn them into fractions with the same denominator because I cannot add or subtract fractions unless they have the same denominator. So what did I multiply 3 by to get to 12? I times by 4. So 8 times 4 is 32. What did I multiply 4 by to get to 12? I multiplied by 3, so 5 times 3 is 15. Then I've got 32 take 15, which is going to give me 17 over 12. Remember, you always keep the denominator the same because it's like if you had, I don't know, let's say a pizza and it had 8 slices. If you had 1/8 and then someone else had 2/8, in total that is 3/8. So the denominator stays the same, it's the numerator that changes. So 17 over 12, how many times does 12 fit into 17? 1, remainder 5. And that's how I do those. So when we're multiplying fractions, people commonly assume that we also need the same denominator. We don't. When we're multiplying and dividing fractions, we just use the numerators and the denominators, but we don't need them to be the same. So once again, we want to turn them into improper fractions. So 4 and 2/3, 4 times 3 is 12, plus 2 is 14. So that would become 14 thirds times by 7/8. And once you've got your fractions, just both as improper fractions, you literally just multiply the numerators together. So we've got 14 times by 7. And 14 times by 7, non-calculator, you could do the multiplication method, or we could just break it up. So 10 times 7 is 70, 4 times 7 is 28, and then you add them together. So just for non-calculator, just try and think of little tricks that you can use to just help you. But if you're super confident with multiplying, then just do that. So that would give you 98 over 8 times 3 is 24. And we need to write it in its simplest form. So what we could do is try and simplify it. So divide by 2 first. So that would be 49 divided by 12. And then we could say to ourselves, how many times does 12 fit into 49? So you've got 12, 24, 36, 48. So that's 1, 2, 3, 4. 4 wholes. And then from 48 to 49, we've got 1 left over. So that'd be 4 and a 12. And then for the division, what we do is almost exactly the same, except with division, you want to always bear in mind, keep, change, flip. So keep the first fraction as it is, change the sign to a multiplication, and flip the final part of the calculation so that it's reciprocal. So 2 1/4, let's write it as an improper fraction. So 2 times 4 is 8, plus 1 is 9. So 9/4 divided by 6. Now, whenever we're dividing by any number, we can always turn it into a fraction by writing it over 1, just to make it a bit easier to navigate with fractions. So keep the first fraction as it is, change the sign, and flip the final fraction. So that would become 9/4 times by 1 over 6. And what does that give me? 9 times 1 is 9. 4 times 6 is 24. And then it says show that it is 3/8. So all I'm going to do is simplify. So find a number that divides into both of them. 9 divided by 3 is 3. And 24 divided by 3 is 8. Okay, so here we're going to be multiplying and dividing decimals. And the key thing when multiplying is to just make life easier for ourselves and to just turn the numbers into whole numbers. So ignore the decimal places and just imagine it as a whole number. So that would be 722 times by 33. Okay, you then multiply this as you would any other thing. So I like using the Napier's bones, but you can use whatever method you prefer. So just multiply the numbers as though they are whole numbers. So 722 times 33. You split the boxes into 2. You do 2 times 3, which is 6, 2 times 3, which is 6, 2 times 3, which is 6, and 6 again, 7 times 3, which is 21, and 7 times 3, which is 21. Then you just go along the diagonals and you add everything in that diagonal. So 6 over here, then 6 plus 6 makes 12. So remainder 1. 6 plus 1 is 8. And then 1 plus 2 is 3. and that would be 2. So I know that 722 times 33 is 23,826. However, what have I done to this calculation? Well, I times 72.2 by 10, and I times 3.3 by 10. So in order to get it back to its original form, what I'm going to need to do, because in total, if I times by 10 and then times by 10 again, I'm timesing by 100. To get it back to its form, I'm going to need to divide by 100. So either you can do it that way, turn it into whole numbers and think about what power of 10 you multiplied it by and then divide it, or the quick shortcut way is turn them into whole numbers and then count how many digits there are after the decimal point. Each digit after the decimal point is a power of 10 that you've multiplied by to turn it into a whole number. So then you have to divide by as well. So essentially, if you've got 2 digits after the decimal point in your calculation, your answer is going to have 2 digits after the decimal point in your calculation. So you can just multiply it like normal and then think, okay, there's 2 digits after the decimal point, so I'm just going to chop my number there and put a decimal point there. So that's how we multiply. Now, dividing is slightly different because there's a special cool law that applies to division. So if we just have a look at this ordinary number, 6 divided by 2 gives me 3. If I multiply each part of the calculation by 10, 60 divided by 30, the answer is also 2. If I multiplied it by 10 again, 600 divided by 300 is also 2. If I then divided it, 0.6 divided by 0.3, that answer is also 2. So with division, it's slightly different to multiplication because as long as each part of the calculation has been multiplied by the same power of 10, your final answer is going to be the same. So when we're doing division, we multiply to make it so that the calculation has at least the last part of the calculation is a integer, a whole number. So if we times that by 10, that would give me 523.6 divided by 14. And now that I have an integer, I can just start dividing. And whatever my final answer is, it's going to be exactly the same. I don't need to do anything with the place value. It's just going to be the same value. So what can I do? Well, it's not the nicest division in that I'm dividing by a double digit number. And if you don't like long division, it can be quite time consuming. You might opt for the more efficient way of just turning it into a fraction, and then you can divide and simplify. So as always, we're going to start by dividing by 2 just to simplify the fraction a little bit. So 14 divided by 2 is 7. And then 523.6 divided by 2, because it's not a straightforward number, we can just use the bus stop method. So 2's into 5 go twice, remainder 1. 2's into 12 are 6. 2's into 3 are 1, remainder 1. And 2's into 16 are 8. So I'm left with 261.8 divided by 7. And what I want to do, now that I have a single digit, I can just use the bus stop method. Obviously, you could have done 523.6 divided by 14 if you're confident and comfortable with long division. But this is just a little cheat way to just get there a bit faster, especially if it's something that you're not confident on, which actually so many people are not. So 7's into 2 go 0, 7's into 26 go, my brain stopped working, 3, 7 times 3 is 21, remainder 5, 7's into 51 go 7, remainder 2, and 7's into 28 go 4. So your final answer would be 37.4. And remember, with division, the answer, the calculation, whatever it is, it's exactly the same, because 52.36 divided by 1.4 is going to be the same as 523.6 divided by 14. Okay, it's just a really cool division trick. Okay, so there are a few ways that we can work out the highest common factor. A factor is a number that multiplies into the given number, i.e. it divides into it. It's always going to be smaller than the number. So you could start by doing factor trees, so like 1 times 75, 2 times whatever, well, 2 wouldn't go into it. Or because I'm being asked to work out the highest common factor and the lowest common multiple of the same two numbers, what I'm going to do is use a factor tree. So what I'm going to do is find out the prime factors of 75 and 90. So let's start with 5, because 5 would be the first prime number that divides into it. So 5 times by, and if you don't know that off the top of your head, just do some working to the side. So 5s into 7 go once, remainder 2, 5s into 25 go 5. So 5 and 15 multiply to make 75. I circle the 5 because it's a prime number, and then I just find 2 factors of 15. 3 and 5 are also prime numbers, so I circle them, and I know that 75 can be written as 3 times by 5 times by 5. I then do the same for 90, so 2 times by 45, circle the 2 because it's prime, and then 9 times 5, so 5 times 9 gives me 45, circle the 5 because it's prime, and then 3 times by 3. So I know that 90 could be written as 2 times by 3 times 3 times by 5. And the highest common factor, remember, it's going to be the largest number that divides into both numbers. So it's going to be smaller than both of them, but it's going to be a factor of them. So because I've got both of these, highest common factor and lowest common multiple, what I'm going to do is a Venn diagram. First Venn diagram is for 75, second one is for 90, and the overlap over here is for anything that is a factor of both. So the first thing that is common to both is 3, so I'll circle that and cross it out and put it in the centre once, okay, because it's common to both of them. Anything else that they have in common? Well, they've got a 5 in common, so I'll circle that out and put it in the centre. And then anything that's left over, so I've got a 5 left over here and a 2 and a 3 left over, goes in their, corresponding Venn parts. So to find the highest common factor, you just multiply the numbers in the intersection. So the highest common factor is going to be 15. Now, to find the lowest common multiple, if this is a calculator paper and you don't like doing the Venn diagram, you could just do the times tables of the numbers and find the first number that is common to both. That's absolutely fine. Remember, a multiple is a number that the number multiplies into, so it's always going to be the number or larger. People always get confused between factor and multiple. Factor is always going to be smaller, multiple is going to be larger, and it's literally just the numbers times tables. So we can do it that way, or what we can do if we've done a Venn diagram, we just multiply all of the numbers inside the Venn diagram. So we do 5 times 3 times 5 times 2 times 3. And I'm assuming this is non-calculator, so 5 times 5 is 25. 25 times by 2 is 50. 50 times 3 is 150. And 150 times 3 is going to give me 450. So 450 would be the lowest common multiple. So this looks like quite a straightforward question, but people always get this kind of a little bit confused. So I'm told that Zion has a bag of marbles, and in the bag, 3/7 of the marbles are multicoloured. Okay, so if you just imagine you had marbles, 3 out of a total of 7 are multicoloured. So 3 out of a total of 7 are multicoloured, and the rest are clear. 27 of the marbles are multicoloured, so I know that 3/7 is equal to 27, and I need to work out the total number of marbles in the bag. So what I need to do is figure out what 1/7 would be. If I know that 3/7 make up 27, 27 divided by 3 gives me 9. So I know that 1/7 must be 9 marbles. And if I know what 1/7 is, I then just multiply by 7 to figure out what the total number of marbles in the bag would be. So either I could split it up into like a little ratio form, or you just leave it as fractions and you do 7 times 9, which is 63. Okay, so with error intervals, what you've been given is a number that has been rounded, and you're always told to what accuracy it's been rounded to. And you need to figure out the maximum number it could be before it would have rounded up to something else, and the minimum number it could have been before it rounded down. So Susanna rounds 7.2 to 1 decimal place. So what we can do is think, okay, well, if it rounded up, it would have rounded to 7.3, and if it rounded down, it would have rounded to 7.1. So it's been rounded to one decimal place. I need to figure out the maximum value it would be before it rounded up and down. And generally, when we have an error interval, we always write it as like the lower bound is less than or equal to the number x, which is less than the upper bound. So there's a lot of kind of debate that this number here, if I think about it logically, this number here could be 7.24999 going on until infinity. But just to make life easier, for the GCSE, the upper bound is just going to be, in this case, 7.25. Because we say that it's a less than 7.25, so therefore it can be anything under this. And similarly with our lower bound, I know that this middle value here, halfway between 7.1 and 7.2, is when it would have rounded down, so that would be 7.15. So the lower bound is 7.15, it must be less than or equal to x, and the upper bound is 7.25. So you literally just find the midpoint between whatever you've been given. If it was 2 decimal places, it would be 2 decimal places, and significant figures the same thing. So just maybe write out like a little line thinking what's the number it would round up to if it did and round down to, and then it's the halfway point. Now sometimes they might tell you that a number is truncated. Now what that means is that it's literally like if I had 72.498979 and it was truncated to one decimal place, I would write that as 72.4. Truncated means you literally put a line after the decimal point and you ignore everything else. So if 62.34 was truncated to 2 decimal places, I need to figure out what it could have been. So the lowest to 2 decimal places, its neighbours would be 0.33 and 62.35. Now remember, it could have been truncated, so I'm not looking for the middle, I'm looking for the maximum it possibly could be. So just like in this case, the maximum value would be 62.349 because I ignore rounding rules and everything. So the maximum value it could have been is that, and the minimum value it could have been is, well, for it to round to 62.33, actually this isn't really helpful for truncating, so I'm just going to get rid of that. But just think about what's the lowest possible value that it could be when you're truncating. So 0 could be the lowest thing. So it would be between 0 and 9. So 62.340 is less than or equal to x, which is less than 62.349. And you could put 349 recurring. Technically, in truncating, they probably want you to write 62.35. But if you put a little recurring sign on top, you signify that you understand what it means and you're technically more correct. So whichever feels more comfortable for you. Okay, so on this question, we're being asked to use a calculator, and it's really important to know what order to do these things in. So you can see you've been given a fraction. So you press the fraction button over here to create a 2-tiered fraction. Then you know that everything inside there is square rooted. So we're going to press the square root button, which looks like this. And then you press sine 30. Now, whenever you press sine 30 or cos or tan, you always need to make sure you close the bracket at the end. And then plus 4.75 squared. And then the squared button is the one that looks like that. And then you take 7.8, take 3.2. Okay, so you type all of that into your calculator, press equals, and it might come up with something like this. So that's like in its third form. So what you want to do if you've got these annoying new calculators, you used to have a nice SD button that I would really like to be brought back. But you press format, and then you go down to decimal, and then it turns it into a decimal for you. So you have to write down all of the figures on your calculator display. The amount of people that don't is a lot. So you're only going to get the mark if you write down everything that you see on your calculator. So write down 1.043 98767. And then you're asked to round your answer to 3 significant figures. So remember, a significant figure is a place value holder. So when you're rounding to significant figures, it's always the first significant figure is the first non-zero digit, but when a 0 is trapped in between 2 numbers, then it counts as a significant figure because it's holding a value as a place holder. So this is the first significant figure, this is the second one, and this is the third one. So to 3 significant figures, I'd round the third significant figure, look next door. Now there's a little poem that you might know. So if it's 5 or more, then you add 1 more to the circle digit here. If it's less than 4, you just ignore and chop everything off and leave this. So that would just be 1.04 to 3 significant figures. Okay, so here I'm being asked to show an inequality on a number line. The key things you need to remember is that if you draw a little dot above the number line, there are 2 ways of representing it. So if it's a blank dot, then it would mean less than or greater than. If you colour the dot in, that represents that it could be equal to that number. So that's the only difference really. So it says -2 is less than or equal to x, which is less than -4. So I'm going to draw a dot above -2 and a dot above 4. And I know -2 is less than or equal to x. So I'm going to colour that one in and then just join the 2 up. Okay. And that way, I've represented on a number line. Now it's saying list all of the integers, so that's just whole numbers that satisfy this inequality. Well, it's super nice because the number line literally shows it for me. So I know that -2 could be a number. Anything in between them is always going to be a value. So -1, 0, 1, 2, 3. So -1, 0, 1, 2, 3. And then because this number is not coloured in, it's not shaded in, it means the inequality cannot actually be 4. It can be 3.999, but it cannot be 4. So therefore, because I'm only dealing with integers, then these are the only values that satisfy this inequality. Okay, so here we've got something to the power of 0, and really quickly I'm just going to show you why it is what it is, just so that you don't just have to memorize a rule without understanding why. So if I think about my powers of 2, 2 cubed is 8, 2 squared is 4, 2 to the power of 1 is 2. So what's happening each time? Well, because it's powers of 2, I'm dividing by 2 to get to my next lower power. So if I continued this, and if I obviously continued it up until infinity, it's the same thing. So if I continued doing this, what actually must the next one be? 2 divided by 2 is 1. And this is the same case for if you were doing 3 to the power of 1 and 3 squared, that would be 9, that would be 3. So therefore 3 to the power of 0 would need to be 1 because it's a pattern that we're following. So anything to the power of 0 is going to be 1. Now for the next question, it's saying write down the value of 3 squared to the power of 5. Now when you've got something in brackets, the shortcut rule is you just multiply the powers. So that would be 3 squared times by 5. But if you don't like memorizing rules and you find this a little bit tricky, then just write out what the algebra is telling you. So that means 3 squared 5 times. So you could write it like this. And then you could just use your powers of multiplication law. But if you still don't like that, you could actually expand it. And that would become 3 times 3. All of these tiny little 3's are expanded to its base, kind of what it means at its core. And you can count how many times 3 is being multiplied by itself. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 3 to the power of 10. So either you remember the brackets law, which is over here. So anything to the power of something and then to the power again, you multiply the powers. Or you can write it out like this and then you use your law of addition. So when you multiply indices, you add the powers. So that would be 3 to the power of 10. Or you can take it down to its base, kind of what it means. Either way, 3 to the power of 10 is your answer. And for the next question, we're combining them. So we've got 3 to the power of 4 times 3 to the power of 7 over 3 cubed. Once again, if you know your laws of addition, you know that that would become 3 to the power of 11 over 3 to the power of 3 and 3 to the power of 11 divided by 3 over 3, using the laws of division, you subtract the powers, so that would become 11 take 3, which is 3 to the power of 8. But let's just take it one step back, just because this is a revision video. What can we do? We could actually just write it out in its pure form. So 3 to the power 4 means 3 is being multiplied by itself 4 times. 3 to the power of 7 means 3 is being multiplied by itself 7 times. And that is being divided by 3 to the power of 3. So when you've got something like this, what you can do is just think, okay, anything at the top of the fraction can cancel with anything at the bottom of the fraction, as long as the calculation on the top is being multiplied and the bottom as well. So 3 divided by 3 is 1. 3 divided by 3 is also 1. 3 divided by 3 is also 1. So you'd just be left with 1 at the bottom and 1, 2, 3, 4, 5, 6, 7, 8 at the top. So that would become 3 to the power of 8 over 1, which is just 3 to the power of 8. So like with everything in maths, if you forget something, if you forget the law, just take it back to its basics and work it out from there. Okay, so some slightly harder fractions here, but like with anything, and this is actually just a really good strategy, if you get stuck, just try and follow the pattern. You know that most things in maths follow a pattern. So let's have a look at what happens with 2. We discovered what happens when you do it to the power of, but let's just have a look at what's happening. So we know that 2 cubed is 8, 2 squared is 4, 2 to the power of 1 is 2, 2 to the power of 0 is 1. And we know that each time we're just dividing by 2. So if I followed this pattern, and it's a pattern because it's applicable to every power of 2, then 1 divided by 2 gives me a half. Therefore, I'm going to have to divide that by 2 again, which would be a quarter. Divided by 2 again would give me an eighth. So if you get super stuck, just follow the pattern. So 2 to the power of minus 3 is going to be an eighth. But the general rule is, if it's a negative, so the negative indicates that it's the reciprocal. Okay, so what is 2 to the power of 3? 2 to the power of 3 is 8. Therefore, 2 to the power of negative 3 is going to be 1 over 8. Another way of writing it is, well, that's 2 to the power of 3. So its reciprocal is going to be 1 over 2 to the power of 3. So especially when we get more complicated decimals, you literally know that it's the reciprocal. So if it didn't have the negative, that would be 2 to the power of 3. So its reciprocal is going to be 1 over 2 to the power of 3. And a reciprocal is literally like 1 over the number. So that's how we'd do that. And because it said to find the value, I can't just leave it like this. I need to actually work it out. But I could have done that as my first step, 1 over 2 cubed, and then figured out that that's 1 over 8. Now, similarly, when I've got fractional indices, what I'm doing is I've got two things. So the first part is the denominator of the fraction tells me what root that is. So because that's a 2, I'm going to have to find the square root. Okay. Up over here, the numerator tells me what it's then to the power of. Now this doesn't have a power, so I could just say, to the power of 1 doesn't change it. So the square root of 16 is just 4. Okay, so something to the power of a half is super simple. It's just the square root. Something to the power of a third would be the cubed root. So let's have a look at a slightly trickier one. Remember, it's the root is the denominator and the power is the numerator. So you always do the root first. So I'm going to say the square root of 25, and then that needs to be cubed. So what's the square root of 25? That's 5. So I need to work out what 5 cubed is. 5 times 5 is 25. Times by 5 is 125. So these are the key things you need to know for the fractional and negative indices. Okay, so in this question, I'm being told that Armand buys a laptop which costs £700 plus 20% VAT. Now, VAT is value added tax. It is what is added on top of the cost of your item. So in America, VAT is added at the till, so you get a nice surprise when you get to the till. You think something costs something, and then they add on 20%. In England, they tend to absorb the cost of VAT into the price, so it's already included. But in this case, it's not. So he buys a laptop which costs £700 plus 20% VAT. So if this is a non-calculator paper, the best thing we could do is start with 10%. So the shortcut for working out 10% is dividing by 10. So 700 divided by 10 is 70. And 20% is double 10%. So if I multiply that by 2, I can multiply this by 2 as well, and I can figure out that 20% must be £140. So he pays £700 for the laptop plus £140 for VAT. So in total, if I add these together, he pays £840. Now, I'm told that he pays £150 deposit. Now, a deposit is money that you pay initially up front in order to secure your item. So you have to pay that there and then. And then you can split up the rest of the money on something called finance, which you pay tend to be in monthly installments. So the total cost is £840. He pays £150 deposit. So let's subtract that. 0 take 0 you can't do. 4 take 5 you can't do, so turn that into a 7. 14 take 5 gives you 9, and 7 take 1 is 6. So I know that after he's paid after he has paid £150 deposit, he has £690 left to pay. So it said that the rest is split into 12 equal monthly instalments. So I'm going to have to split that remainder into 12. And remember, if you really love long division, that's great. You just do it. If you don't, then you can make your life a little bit easier by just turning it into a fraction. 690 divided by 12. I can divide this by 2, divide this by 2. And that would give me, so 690 divided by 2. Let's use the short bus stop method. So 2's into 6 go 3, 2's into 9 go 4, remainder 1, and 2's into 10 are 5. So that would be 345 divided by 6. And whenever you've got a nice single digit number, then you can just use your bus stop method. So 6 is into 3, go 0. 6 is into 30, go 5, remainder 4. 6 is into 45, go 7, remainder 2. And when you run out with a number, just add zeros here and then put the decimal place. So 6 is into 42, so there's a remainder of 3. 6 is into 30, go 5. So therefore, 690 divided by 12 is £57.50. Remember it's 57.5, but it's money, so we turn it to £57.50. So the cost of each monthly payment is £57.50. So just two key things: VAT, value added tax. You pay it on top of the price, and then a deposit is money that you pay at the beginning. So you take it away from your total, and then the remainder is what you're left to pay. Okay, so here I've got a question that combines quite a few math skills. Now, people seem to get really sort of frustrated or put off by worded questions, but it's always going to be generally quite simple topics. It's just they've clumped them all together, and you have to just follow a process, work through it bit by bit. So always start by reading the question and highlighting or underlining really important bits, and then annotating the bits that you've worked out so that you don't get lost in your working. So I'm told that a catering company is organising prom for year 11. There are a total of 150 students. The number of girls to the number of boys is 8 to 7. So the first thing I can do is just work out what the number of girls must be and what the number of boys must be. So it just helps to dissect the information. So I know it's 8 to 7. So to work out ratio, if you just pictorially just looked at it, for every 8 girls, there are 7 boys. So in total, every time you're splitting it, you have 15 parts in total. Okay, so whenever we work with ratio, we always add the parts together and then divide the total number by those parts to figure out how much one part must be. So 150 divided by 15. Remember, if you don't like dividing, you could turn it into a fraction. But with this, we should be, so let's divide by 5 maybe, or 3. Let's divide by 3. So that would become 50 divided by 5, and then 50 divided by 5. You might be able to recognise that that's 10. But either way, you can use the fraction, or if you spotted that 150 divided by 15 is 10, then we know that 1 part is equal to 10 students. So therefore, if the girls represent 8 parts, each of these little parts is going to be 10, and therefore the girls is going to be 10 times 8, which is 80. And the boys will similarly be 10 times 7, which is 70. Okay, so you've worked out one key piece of information. And remember, with questions like this, and with any question on the exam, it doesn't necessarily, obviously it's great if you get the final right answer, but like you can pick up so many marks just by doing the working. So it's really never, 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 ever worth it leaving a question, even if it looks confusing and complicated and annoying. So each girl and each boy gets to choose either a vegan, vegetarian or meat meal. So there's 3 options. A quarter of the girls choose a vegetarian meal. So I know there are 80 girls. A quarter, how do you work out a quarter? Well, a quarter is just whatever the whole is, split into 4. So 80 divided by 4 is 20. So I know that 20 girls choose a vegetarian meal. 65% of the girls choose a meat meal. Okay, so if this is non-calculator, let's start by working out 10%. I know that 10% of 80 is 8, so therefore 60%. If I times this by 6, I can times this by 6 as well, and 8 times 6 is 42. Is it? My 8 times 6, 10 times 6 is 60, so 48. Oh my gosh, it's a very hot day today. It's 24 degrees outside, so blame the heat. 60% is 48, and then how do you work out 5%? Well, if you know that 10% is 8, you can divide by 2 to get 5%, so that would be 4. Okay, so 48 plus 4 is 52. So you know that 52 girls have a meat meal, and the rest of the girls choose a vegan meal. Work out the number of girls that choose a vegan meal. So this wasn't actually such a bad question, and maybe if you read to the end first, you might have not wanted to ignore this question, but it's just like, it's just using ratio, then percentages, then fractions, and just do it bit by bit, and you'll be led to the answer. So we know that there are 80 girls in total, so 80 take 20 is 60. 60 take 52 leaves me with 8. So therefore 8 girls choose a vegan meal. And that's how we do that. Okay, now this is another question that frequently is just ignored on the exam, and I think it's because it's sort of taught to you really, really early on. It's so simple that you forget about it. So if you are told something is simple interest, A, that's not the best investment. You should always go for things that are compound interest. And B, it means it is quite simple to work out. So Arian invests £500 for 3 years, offering an annual interest rate of 5% simple interest. That means you only earn interest on the original value that you put in. So let's have a work of finding 5% of 500. Remember the trick, we know 10% you can find by dividing by 10. So 10% is going to be 50, and therefore 5% is half of 10. So 5%, I'm going to half 50 as well, would be £25. So I know that 5% is £25. And with simple interest, all that happens is that initial interest that you get paid on year 1, you get paid forever. So if you had a simple interest of £25 and you invested that money for 40 years, each year you'd only be getting £25, whereas with compound interest, it would be compounding. So you'd be getting 5% of the new value, and then the new value, and the new value, and the new value. So simple interest is not a great investment choice. But Arian decided to make that investment. So what do? You find out what 5% is, and then you literally multiply it by 3, because each year he's going to be making £25. So 25 times by 3 is £75. And you're asked how much is in his account at the end of the 3 years. So at the end of the 3 years, he'd have 500 plus the £75, and that is what he'd have. So with questions like this, it's really important to read the question and not assume you know what they're asking you for. So it says the normal price of a table is reduced by 30% in a sale. So if the normal price is 100% and it's reduced by 30%, then what I am dealing with is actually 70% of the table. So Hergy purchases the table in the sale for £770. So therefore, I know that 70% of the table is worth £770. What people often do is they assume that 100% is 770 and then they work out 30% of 770 and get themselves into a bit of a mess. So read the question carefully. You know it's been reduced by 30%. Therefore, the value that you are paying for is 70% of the original. So if I know that 70% is 770, I can find out what 10% must be by dividing by 7. 70 divided by 7 gives you 10. And 770 divided by 7, well, I can turn it into a fraction. And then that doesn't help me. So 7 instead of 770 would be 110. So 10% would be 110, and you are looking for the normal price. So the normal price is 100%. The original value or the normal price or anything in those words is 100% of the table. So to work out 100%, what do? I'm going to times by 10. So therefore 110 times by 10 is going to be 1,100. And the normal price must be that. Okay, so this is reverse percentages. You're not working with the original amount, the full amount. You're working with part of the original or more than the original. So if this was a calculator paper, you could divide by 100 to figure out what 1% is, and then or no, in this case you would divide by 70 to find 1% and then times by 100. But it's non-calculator, so the safest thing would be to probably just work out 10% and then just use your multiplier unit method. Okay, so in this question, I'm told that Bianca buys a new TV and that 20% VAT is added to the price of the TV. Remember, VAT is value added tax. It's additional money that is added onto the price of your item. Bianca then has to pay a total of £1,000. So the original value of your item is always going to be 100%. Anything additional to that is on top of that. So she has paid 20% tax on top of the 100% purchase price of the item. So in total, she is paying 120%. So I know that 120% is equal to £1,000. I need to work out what the price of the TV is with no VAT added. So what I need to do is use reverse percentages in order to work backwards. Now, if I know that 120% is £1,000, what I can do is work out what 1% is, or I could work out what 10% is, which makes more sense. Let's work out what 10% is. Okay, so 120 divided by 12 is going to give me 10%. So if I divide this by 12, I can divide this side by 12 as well, and that will tell me what 10% is. So 1,000 divided by 12, I can turn it into a fraction just to make life easier for myself, would be 500 divided by 6, which would be 250 divided by 3. When it gets to a nice number that I can just turn into the bus stop method, I could have done that here. Then you just divide using the bus stop. So 3's into 2 goes 0. 3's into 25 are 8, remainder 1. 3's into 10 are 3, remainder 1. And then you put your decimal point and you just add a bunch of zeros. 3's into 10 go 3, remainder 1, 3, remainder 1, and so forth. So I know that I'm going to be left with a recurring decimal. So £83.33 recurring. So 10% is 83.33. And then to work out 100%, what I would need to do is multiply by 10. Now, just as a, I forgot what the word is, that disclaimer, if this is calculator paper, the best thing to do would be to work out 1% and then times it by 100. But this is non-calculator. You could also have done that, but you could also find other ways to just make your life a little bit easier. So 100%, I times that by 100. I times that by 10. So that would be £833.33. 33 pence. You could round it to £833.34. It doesn't really matter as long as you've shown you're working, then that's fine. So let's just say 34 pence because they always round money up. Okay, so in this question, I'm told that at the end of 2021, the value of Joshua's house was £250,000 and the value of Rinwar's house was £180,000. 2 years later, at the end of 2023, the value of Joshua's house had decreased by 20% and Rinwar's house had increased by 10%. So I need to figure out whose house had the greater value at the end of 2023. So let's start with Joshua's house. It was worth £250,000, but then it fell by 20%. So what is 10%? I just divide by 10. So 10% is going to give me £25,000, and therefore 20% is double 10, so that's £50,000. So his house fell by 20%. So if I subtract £50,000, I know that at the end of 2023, his house is worth £200,000. Now let's compare it with Rinwar's house. So let's just leave his working. So Joshua, his house is now worth £200,000. And then let's figure out what happened with Rinwar's house. So he bought it, or the value of it was £180,000. And then it's increased by 10%. So what's 10%? Divide by 10, that's going to give you £18,000. And then we want to add it on because it's increased in value. Remember, decrease means fallen in value. Increased is risen in value. So that would give me £8,919,000. So it's actually super close. But despite the fall, Joshua's house still had a greater value, only by £2,000. So we could say Joshua by £2,000. Okay, so a percentage profit question. I'm told that Mariam buys 6 kilograms of sweets to sell. She pays £15 for the sweets. She puts them all into individual bags. She puts 500 grams of sweets into each bag. Okay, so if she buys 6 kilograms of sweets and puts 500 grams into each bag, there's in 1 kilogram, that would be 2 bags of sweets because there's 1,000 grams in 1 kilogram. So therefore in 6 kilograms, 2 times 6 is 12. So I know that she has 12 bags of sweets. Now she's paid £15 for them. So the cost is £15. And she sells each bag of sweets for 75 pence. So I'm going to have to do 12 times by 75. You can do this whichever way you want. Actually, we could do it a doubling and halving way. So let's half one part of the calculation, double the other. So 6 times 150. Do that again. Half one, double the other. 3 times 300 is 900 pence or £9. Sorry, she hasn't made very much money. She hasn't made any money at all. So £9 sells for £9. Work out her percentage profit. Well, sadly, she should have either, I think, sold them for 50 grams, but she didn't. So if the original price is £15, her percentage loss is the original value. So £15 take away 9 gives me a loss of £6. So when you're working out percentage profit or percentage loss, you're working out the difference between the original and the new. So in this case, the difference between the cost and how much she sold it for is £6. So that is her percentage loss. And 6 over 15, I then times it by 100 to turn it into a percentage. So 6 divided by 15, I can once again turn it into a fraction. So divide by 3. So that would be 2/5, which you either know is 0.4 or you can do the bus stop method. So I know that 6/15 is equal to 2/5, so that would be 40% loss, sadly. So even though it says work out her percentage profit, that might be a trick question because it's actually a loss. She has sold them for £9, but she bought them for £15, so she's made less than she paid. Okay, so in this question, the key thing that I want to pick out is that it asks me to estimate. So if you're being asked to estimate, then you need to round each part of your calculation generally to one significant figure. The whole point when estimating, you should be able to do it in your head. It should not require any calculations. So Suman buys a vase. The cylindrical vase has a height of 19 centimetres and a radius of 3 centimetres. Find an estimate for the volume of the vase. So what's the formula for the volume? Well, the volume of any prism is the area of the cross section, in which case if it's a cylinder, if it's a cylindrical vase, the cross section is going to be a circle, and then you just times it by the length or the depth or the dimension that's not involved. Okay, so I know the height is 19 centimetres, and I know that the circle part has a radius of 3. So how do you find out the area of a circle? Area is pi times by radius squared, and we're trying to estimate. So even though pi has a value of 3.142, this is a non-calculator question, so you're just going to round pi to 3. You're going to do 3 times by 3 squared, so 3 times 9 is 27. So we know the area of the circular part is 27 centimetres. And I know that the height is 19 centimetres, but I'm trying to do something that I can do in my head. So I round this to one significant figure, which is 20 centimetres. 3 is already one significant figure, so we don't need to worry too much about that. So 27 times by 20. Remember, you can double and halve. So if I halve this to make it 10, I'm going to have to double this. So 20 times 2 is 40. 7 times 2 is 14, so that would be 54. So my estimate would be 540 centimetres cubed. Okay, so this relies on you knowing how to work out the volume of a prism. Remember, it's the area of the cross section times by the length. And yeah, we round to one significant figure. Once you've got your answer, you don't round your answer, you just round during the calculation. So now use your answer to part A to estimate the number of vases that Suman could fill with a 2.5 litre watering can. Okay, so 540 divided by 2.5. Now this is tricky because generally you should be rounding to one significant figure, but 2.5 is a tricky one. So I think there'd be quite a wide range of answers that would be available to you, but I think it's because we've estimated in the top question. So if we do 540 divided by 2.5, you know that 2.5 you can turn it into a fraction, which would be 5 divided by 2. And when you multiply, divide fractions, you keep, change, flip. So that would be 540 times by 2/5. 540 times by 2 is 1080. 1080 divided by 5. So maybe they did want us to round it down. So let's say that I rounded it down to 500. Then 500 divided by 5 is 100. But if you did this, I think you'd also be fine. 1080 divided by 5. So 5's into 1000 go 200. I meant 200. 200 and 5's into 80 go 16. So that would be 216. Or if you said 200, I think you'd also be fine. These ones are always really tricky because you have your logic, your real world logic, and you know that sometimes you're like, well, I can just do that. But generally when you want to estimate, you want to round to one significant figure. Now, the last part that we want to do is something where you have to estimate the value of a square root. So this is slightly different because what you need to do is think about all of the values of the square roots that you know. So square root of 76. What are the square numbers surrounding that? Well, I know that 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64, 9 times 9 is 81, 10 times 10 is 100. So the square root of 76 is in between these two square numbers. Now the square root of 64 is 8, the square root of 81 is 9, so I know that the square root of 76 has to be somewhere in between 8 and 9. 76 is closer to 81, so I'd probably say that's maybe 8.6, but you're just estimating, so it doesn't really matter, as long as you recognise that this square number must lie in between these two. So you're using the existing square numbers in order to estimate this one. Okay, so another estimating question. So the diagram shows a shape made from 8 identical squares. The total area of the shape is 414.72 centimetres squared. So it's an estimating question. So I am going to say that the total area is 400 centimetres squared. Round it to one significant figure. Find an estimate for the perimeter of one of the squares. Give your answer correct to the nearest whole number. Okay, so I know this is made of 8 identical squares. So if I do 400 divided by 8, that will tell me the area of one of these squares. Okay, so 400 divided by 8, just turning it into a fraction, is the same as 200 over 4, is the same as 100 over 2, which is 50. So each little square is 50 centimetres squared. Now, I need to estimate what the side is in order to work out the perimeter. So whenever you have a square, let's say this is 25, to find a side, the length of a side is the square root of the area of the square. So this is 5. I know 5 times 5 is 25. The area is the side squared. Okay, so the side squared is going to be the area. If I know that the area of this is 50, remember what I did with my square roots. Think about what your square numbers. So you've got the square root, you've got 6 squared, which is 36. 7 squared is 49. 8 squared is 64, and so forth. So the square root of 50 is going to lie in between square root of 49 and square root of 64. It's a lot closer to the square root of 49, so I'm going to say it's 7.1. In reality, it's probably a little bit less, but 7.1 is absolutely fine. And then it says give your answer correct to the nearest whole number. So I could say that this is the perimeter. So if that's 7.1, 7.1 times 4 is 28.4, but it wants it to the nearest whole number, so the perimeter is going to equal 28. Okay, so this is a slightly complicated question in that I think a lot of people aren't familiar with the whole estimating with a square root, but if you ever have to estimate with a square root, it's slightly different rules. You don't need to worry about rounding to one significant figure. You worry about where the square root is in relation to other square roots that are whole numbers. And that is the end of the number part.